here. His name is Ilya Prigogine. He's a Russian guy that went to Belgium, did chemistry, won a Nobel Prize. When he was 64 years old, he won a Nobel Prize. 65 was the mandatory retirement age at that university, and they forced him to retire. He went to Texas and opened the Chaos Institute, and most of the chaos theory stuff happened from him. So, to me, the intellectual heritage is so important because essentially he was so pissed off at what happened to his professor that he dedicated his life to studying this stuff. This stuff he called far from equilibrium physics. Far from equilibrium physics, if you want to, I have show and tell with me today. This little book was the last book he wrote. He died 3 years ago. It talks about the fact that when you're away from equilibrium by a little bit, everything's sort of smooth. But if you get far enough away, strange things happen. Essentially, phase changes of state happen. But also, self-organizing systems happen. He called them dissipative structures. They're structures because they're orderly. They're dissipative because energy is flowing through them and entropy is happening. Something happens to hold those things in that structure for quite a long period of time relative to what you would think by just reading the textbooks on thermodynamics. And so the persistence of these away from equilibrium structures is essentially the study of systems. And whether you go about it from the Santa Fe Institute way, or the Michigan way, or the Alamos way, or the Prigogine way, it's the same math in every case. It's the math of turbulence. And today, I believe it's still true, although I'm not an expert in it, I believe it's still true, we don't have any formula that can describe turbulence for you. You know, turbulence happens. And sometimes then it's over. But when it happens, you've got a mess on your hands. To me, obviously in the area of economics, market failure, turbulence, non-price rationing, all those things, which my next show and tell is Friedrich von Hayek's Individualism and Economic Order. He wrote a paper in 1935 and another one in, 39, another one in 1945, describing economies as information networks that solve the most important problem to him as well as to other Austrian guys, which was the division of knowledge, not the division of labor. And a price system is a low energy solution to how to provide knowledge to the people who need it to do their thing. And it does not deliver knowledge you don't need to the people who don't need it. And it does so in tiny packets or photons. Those packets are prices. And so it's an information distribution network. Actually, when Hayek was 19, he wrote a paper that was the first neural network. And he didn't publish it until the 1950s. Laid in a drawer for all that time. So Hebb did not discover neural networks, Hayek did. Although if you read the book, you'll never be able to understand what he says. It's the worst written book I've ever read in my life. So Hayek's a hero, I think, for understanding that the reason market economies beat in competition non-market economies is because of the information efficiency of this price network. So I like to think of it as a freeway system. Like when the freeways are working, it's the fastest way to get from here to there. But sometimes they don't work. And sometimes something happens. There's a wreck, or they clog up, or they're shut down. At which point, you know, you ask, well, does that mean you can't ever get home? No, it's just going to take a hell of a lot longer to get home. And that efficiency we choose to measure with GDP. If you were doing it as a physicist, I think it'd be better called gross national work in a physics sense. Nevertheless, we're measuring energy transformations. We transform coal into product, or we transform human energy into a service through a series of ongoing energy transformations. So what I want to do is take the spirit of these guys and talk about what that implies about what we're doing. I'm going to do it kind of in short, quick hand so we can get to other topics. Right? The sun's hot, the earth is cold, energy flows, heat flows from the sun to the earth, a lot of it. Okay? We all know -3 degrees is the Earth's surroundings, and that is anywhere from 15 million to 4 million degrees. And so basically, that energy flow drives everything you've ever seen on Earth that moves. So all physical change. Work in this business is called kinetic motion. It's also called it differs from thermal motion, which essentially is motion that is not coherent. So work is coherent motion as opposed to incoherent motion. And heat is just the result of incoherent motion crashing into each other. So in economics, that would be product and cost, or waste, or all those things we talk about. So the difference between those two things always fascinated me. The other thing that fascinated me is my whole career I've been way interested in the understudy of balance sheets in the economics profession, especially non-financial assets. And a balance sheet is really a store of something. What is it a store of? I think it's a store of vintage solar energy. Because the energy that rains down, you know, some of it bounces off and we measure it with albedo, and some of it sinks in, warms the dirt, and grows grass and trees, and we eat the green stuff. Animals eat it too, and we eat them. And so basically all the forms of economic activity after that are ways of converting one form of stored energy into a different form of stored energy that we find more useful. This is not an anti-market way of looking at it. What it is it says that there are energy gradients or temperature differentials or pressure differentials that drive change. And in economics, we call those marginal rates of substitution. If you have a relative price and the marginal rate of substitution that are different, it doesn't stop. Something changes. And it changes until that is true, at which point you have equilibrium, which is boring, as we talked about earlier. But so essentially, you've got all this stuff raining down. It gets stored. It gets stored in different ways. Some of it gets stored in oil and gas and coal, which is really just vintage dinosaurs. If you had a bottle of dinosaur juice, 250 million years old, that's oil. We store technology, because Thomas Edison died, but we still have the lights on. We store energy in the form of people by teaching them things, and then they go do things later. So that's the roundabout production from the Austrians. And we store it in the form of tools, which economists call capital stock. Capital stock is just something that makes work energy more productive than it would be if you didn't have it. So tools. Problem is, those things aren't stored around the world in a homogeneous way. So if there were no transactions or trade, there'd be huge differences in relative prices around the world. Because in Kuwait, gas is free, and in Asia, human labor is almost free. It's because of the resource imbalances. If you connect them together, we have a thing we call trade. And trade is really energy flows driven by gradients, or return gaps, or price gaps, or wage gaps, or which is exactly heat, pressure, or energy bond gaps in chemistry. And the metaphor, the sort of Leonardo metaphor, is you've got two wash tubs, one's full, the other's empty, and there's a wall in between, nothing happens. If you poke a hole in the wall, it leaks over, and it stops. So that's basically the story of the world, is the non-equilibrium driving change until it runs out of juice. It runs out of juice when the gradient goes flat. So if you want to look at it as physical capital, in that map I showed you earlier, almost all the physical capital in the world is bottled up in North America, Western Europe, and a couple more places. All the people are bottled up in Asia, and all the dinosaurs are bottled up in the Middle East and a few more places. So in the area of physical capital, we've got it and they don't, so there's a big relative return differential, which is a relative price differential of the capital stock. And when you open trade, capital moves, so that's capital flows. But I could take the same thing and just turn it exactly on its head, and it would look like that. In which case it would be human capital flows. And so this one, this one's FDI from the point of view of China. And this one is illegal immigration, legal immigration, outsourcing, optical fiber, all those things that now move energy around the world. And the thing is, when we write about it, we tend to write as if those adjustments are rather gradual and benign. For a reason, because the capital stock of America is, X trillion dollars. The capital stock of anywhere else is X trillion dollars, and the largest ship in the world carries 11,000 containers, 20 feet long. And it takes 2 weeks. So essentially,